Okay, we're going to take a look at our warm-up. I'm pausing for 1 second.
Period, but because it took up time and we were like so squished, we're like, I didn't like pushing that fast, so come on. Okay, so my hint to all of you was to find S prime and make a sign line, which looks like every single group did. Well done. I like that you all realized to start your sign line, most of you realized to start your sign line from 0, because that, in the context of the problem, it wouldn't make sense to include years when the company didn't exist, right? So we're talking about years from 2005. So we want to start at 0, which represents 2005, and just go forward from there. So let's go and find very quick. Someday I will remember. Okay, so S prime. So we get 6x squared minus 42x plus 60. What are we going to do with this? Factor. Set it equal to 0 and factor, right? So set it equal to 0. I'm going to factor, first I'm going to factor out a 6. You can divide by 6 or factor it out. As long as the 6 is positive, it really, I don't yet. I'm going to just pull out the 6 first. All right, so we have 6 times x squared minus 7x plus 10. All right, so we get x, 2, 5, minus, 2, and 5 are our critical numbers. So then we make a sign line for S prime with a 2 and a 5 starting at 0. Whenever you make a sign line, it's good if you label your sign line. And just because it helps you know that how do I say this? Today we're going to do problems where in one problem you're going to have multiple sign lines. And each sign line is going to be for a different thing. So you don't want to get your sign lines all mixed up. So the label helps you, number one, just to keep track of which sign line is which. But number two, the label tells you where to plug in. Wherever I got these numbers from, if I got these numbers from S prime, that's where I'm plugging in to find my signs. Okay? So because the whole point is I want to know where is the derivative positive, because wherever the derivative is positive, that means the slope is positive, which means the function is increasing. All right. So this sign line, plus, minus, plus. Whenever I make a sign line, I'm gonna teach a lot on the warm-up right now. When I make my sign lines, I like to put little arrows under the signs. You don't have to do this. Nobody grades your sign lines. It doesn't matter. It's a visual aid for me. I am a very visual person, so I like to have these little arrows. So whenever I have a plus, I put a little arrow going up, and when I have a minus, I put a little arrow going down. That helps me for two things. One, it's like I look at the arrows to say, increasing, increasing, decreasing. And I can see my maxes and my mins because it's kind of like the top of a little hill and the bottom of a little valley. So I can see there's a max at 2 and a min at 5 just by looking at my arrows. So it helps me. You don't have to do it if you don't like to, but that's what I do. It's a personal thing. Okay. So anyway, all that being said, let's look at the first question. Determine the intervals of years where sales were increasing. So they asked us for years. So the first thing you want to do, which I keep trying to get you guys to read answers in context, and I see so many boards where you're still not answering the question that's being asked. So the question didn't say X values, the question said years, right? So well done, the middle group, well done with giving me years. Thank you, good job. All right, so, okay, this group gave me both, so I'm just looking for the years, so I would take that, even though I would be kind of like this is a group where it's kind of a CYA thing, like, well, we think she asked for years, so we're going to put years, but we're not positive if that's good enough, so we're going to put both just in case. I don't like that, because to me, that's more of like, you're not firm. You're kind of like giving me everything and hope, like you throw it at the wall and see what sticks, right? So I want you to just pick one and go with it. But in this case, I asked for years. So year 0 is 2005. So if this is 2005, this is 2007, this is 2010, and then that's forever. So I would say for part A, sales were increasing from, and it doesn't have to be, I didn't ask for anything fancy, right? So 2005 to 2007 and 2010 to forever. Okay. And then sales were decreasing. Sales were decreasing from 2007 to 2010. Now, the good news is you all figured those answers out. Every single board got this correct in some capacity. It's just that I'm being picky on how you write it, right? But you all got the right numbers, so well done with that. All right. When did sales reach a maximum? I didn't give you an adjective, but to me, and I know I said like when there's no adjective, it means absolute. But in the context of this problem, it really is implying more like, hey, when did your sales hit a max? Well, they hit a max in 2007. So that's really what I was looking for, so which I see. So some people put ad infinity, okay, because you're being very literal. I get that. But I was really just saying, like, if we're talking, on the street, right? So, when did your sales hit a high point? Oh, well, we hit a high point in 2007. Sales hit a max in 2007. And when did your sales hit a low point? Sales hit a min in 2010. Okay. How does your outlook for the future look based on your sign line? Pretty darn good. Pretty darn good. A-okay. Good. Sales will go up. It will be A-okay with a happy face. Yes. What does Gucci mean?
Oh. It's like slang for good.
Gucci is slang for good because of the brand Gucci? Kinda. Brighter than mine. Brighter than mine. I think pretty much everyone in this room has got positive prospects on the horizon. So, yeah, you all have bright futures ahead. Not brighter than yours. Okay. All right. So anyway, that's just a warm up, just to kind of get you into the feel for what we're going to be doing today. Yes, Luke?
Why is the minimum not 2005?
So I should have put, if I wanted to be literal, I should have put local, because that's really what I was looking for. I was looking for local maxes and mins, but I wanted you guys to just think of it in context, not literal in math. And so kind of like if you were just talking to someone in a conversation, hey, when did the sales hit a min? You wouldn't say you hit a min the first day you started. I mean, of course your sales are at a min on your first day because you haven't sold anything yet, right? But I wouldn't call that like the low point for the company. I would just say that's when we started, right? So when we're hitting a min, it's really like, sales dipped down, right? And hit a low point. So that's kind of what I was looking for here, was not like major math literal context, but more just kind of if you're on the street talking about the costume company, how would you talk about it? Okay. Anyway, however, just so you know, on your test and on the AP exam will be very, very literal. So there's no interpretation. It'll be cut and dry. So you don't have to worry if you're like, oh my gosh, how am I supposed to know then? Don't worry. We're super literal on every single test. So there's no interpretation. Okay, so today, I didn't go to the title page. So today we're doing section 4.3, and this is actually wrong. It's section 4.3 part A. So we're doing 4.3 is huge. It is a huge section of this new book. It covers what would in our old book have been 2 sections. So we split it in half, but even splitting it in half, it's still a big, big lesson today. So we're gonna kind of move. Tomorrow's lesson isn't as bad. Tomorrow's lesson's a little bit shorter, which is good because tomorrow is Thursday. It's a short day. So 4.3a, I know how derivatives affect the shape of a graph. Right? Okay. So the first thing that we need to make sure we have down in our notes is that whenever f is increasing, that means that f prime is positive, and vice versa. When f prime is positive, that means that f is increasing. Whenever you see a double pointed arrow like this in math, this is it means the statement is what's called biconditional. And so it means it's true in both directions. If this, then this. If this, then this. So if f is increasing, then f prime is positive. If f prime is positive, then f is increasing. True in both directions. That is a true statement both ways. Same thing for decreasing. If f is decreasing, then f prime is negative. If f prime is negative, then f is decreasing. Today our whole focus is going to be on relative extrema. On this graph, there are letters A, B, C, D. What 2 letters have relative extrema associated with them? B and C. You will not have relative extrema at an end point, only in the interior of an interval. So B and C will both have relative extrema. A would be an absolute min, and D would be an absolute max, but those would not be relative mins or maxes. So B would be a relative max, C would be a relative min. Okay, any questions about, you have all this down? Not that much? Okay. The other thing, I'm going to mention this real quick. So, relative extrema, when you write these, you write them as ordered pairs. So absolute extrema, I've like hammered it in that those are y values, and I'm really happy to discover after looking more closely at the homework that your book also expects you to type them in as y values, which made me real happy. So absolute extrema are always y values. Relative extrema are always ordered pairs, because both the x and the y can be different for every relative max and min, so we traditionally write them as ordered pairs. Once in a while, the College Board will say, just give us the x values, but usually they're ordered pairs. Oh, and the other thing you should all know, remember that relative extrema, does anyone remember there's another name for these? Oh, good. Wow. Okay. Local extrema. So if you see local, same thing. Right? So relative and local, same thing. All right. Let's move on. So this test, the first derivative test for relative extrema, you need to write this down. And you need to write down all those because statements. The first derivative test for relative extrema is kind of like, it's like an algorithm for finding relative maxes and mins. It's a procedure. So the first derivative test for relative extrema is a procedure for finding relative extrema. The procedure is you find your critical numbers, you make a sign line, and you write your answers. It's not a hard procedure, it's not a long procedure, but it's a procedure. The biggest, most important part of this procedure are how to write your answers. When you write those because statements, write them exactly how they are presented. You can, if you want to write in full words, I always abbreviate. I don't like writing the whole thing out. There's, especially since in years past, before we had online homework, I made my students write these with every single answer for every single problem. They had to write a because statement or I wouldn't accept the homework. Now you guys are, I guess in one sense, lucky that you have online homework so you don't have to write it all, but unlucky in that you're not going to get to practice with writing these. So the way that we're going to make sure that you practice writing them is we're going to do a lot of them in class. And you're going to be writing these statements every single time. When you write your answers with your because statements are your justification. When you write your answers with your because statements, do not paraphrase the because statements. Do not make up your own because statement. Just copy. Just be a sheep exactly as it's written. This is exactly what the College Board is looking for. Verbatim. Don't change it in any way. I'm going to mention one more thing while you guys are writing. When I write AB, that's an interval. So if I say f of x is increasing on, that's an interval from A to B, right? So when I say AB, that's an interval. When I say xy, that's an ordered pair. That's a point. So we don't have a relative max on an interval. We have a relative max at a spot, right, at one point. So AB implies an interval, the interval over which we're increasing. XY is a point. It's an ordered pair. Yeah, Luke.
Oh, sorry.
Oh, that was quick. Okay.
What is the worst word that you can say in this class, Casper? It. Do not ever use a pronoun when you are writing these because statements, or you will not get credit. So if you say it is increasing, or if you say F is increasing from 3 to 5 because it is positive, or the sign is positive, or anything that is not the name of what you're talking about, we have to assume you don't know what you're talking about, and we're going to take off the points. So please, no pronouns. Just write exactly as you see this. Write it exactly. F is increasing because F prime is positive. Okay, all right, I got to make sure because some of you guys in this room are really, really literal. So if the function's called G, please call it G, right? Okay, don't say I had to call it F because you said I always have to call it F. So make sure you follow the function name that's given. If like in the last problem we called it S, right? You would say S is increasing because S prime is positive, right? Follow the function name that's given. College Board used to not take off. If they called a function G and in your answers you called it F because you're so used to writing F of X all the time, they used to accept that. Then 2 years ago, they said we are going to crack down on notation, and now that includes correct function names. So if they call a function W of t, and in your because statement you write F of X, you will not get credit for your because statement, even if it's perfect. So make sure you use the function name they give you. Okay? All right, good. Everyone have these down. I know it's a lot of writing. Okay. All right. First problem of the day. Find where the function f of x equals that lovely polynomial is increasing and decreasing, then locate the relative extrema. So the first thing I want you all to do, once you write the problem down, is I want you to find f prime and find the critical numbers, then stop and check with your group mates to make sure you match before you move on and make your sign line. So write the problem, find, okay, so our derivative, sorry, but those of you watching the tape, you're going to see that every time. Here we go. Okay. F prime is 12x cubed minus 12x squared minus 24x. So I'm going to go ahead and just set that equal to 0 and write
A relative then
12x
occurs at point
times
-1.
x squared minus
It's the second one.
x minus, and then we factor, okay, x 1 cubed minus plus, so we get x equals 0, -1, and 2. All right, I hear good discussion going on. All right, I'm going to go ahead and call your attention back up to the front, because most of you at least got to hear, I think everyone got at least to hear. Did you all find all 3 critical numbers? One of the biggest mistakes that calculus students make is dividing out a variable. And you know where it happens the most often? Is if you have an equation, something like x cubed equals x squared kind of a thing, people want to divide an x squared out and just get like x equals 1. You have to always move everything to one side and factor, because if you don't, you're going to lose a solution, right? We never divide out a variable ever. We always write all of our variables. When you have a cubic equation, 3 x's means you should have 3 answers unless one of them is repeated, right? So 3 critical numbers, 0, -1, and 2. -1, 0, 2. I'm going to give you a few tricks, sign line tricks. You don't have to follow these tricks. Not everybody likes these tricks. Anything that shortens my time of work, my work time is a happy thing for me. So I tend to use the tricks because I'm very comfortable with them. You don't have to. This is just, if you want it. So, couple quick things. When your factors have an odd multiplicity, multiplicity is basically your exponent on your factor. It means how many times does that factor occur, right? So this factor occurs once, once, once. All of these have an odd multiplicity. When your factors have an odd multiplicity, it means the sign is going to change on either side of that critical number. If your factor has an even multiplicity, say we had like x minus 2 squared times x plus 1, right? Even multiplicity means you're going to have the same sign on both sides. Why is that? Last year, I'm hoping that you learned something about graphing. When you have a graph, a factor with an even exponent, it's going to hit the x-axis and then bounce back off. That means that your sign, you're not going to cross through the x-axis, so your sign's not going to change. But when you have an odd multiplicity, this is a -1, so when you have an odd, you go right through. When you have an odd multiplicity, your sign changes. So, if your factors are all odd multiplicity, which they often are, then you know that your signs are just going to alternate plus minus, plus minus, plus minus. So you just have to find one of them and then just alternate, right? So I always find one sign, but make sure you do it right. So, because otherwise they're all wrong. So I find one sign and then I use my multiplicity to fill in the rest. I find it easier to find the positive one. So I usually start on this end and go this way instead of on this end and go this way, but it doesn't matter. So if I pick 10, positive, 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 I'm positive, negative, positive, negative. There's my sign line. So, did you have a question? No? Okay. Remember, label your sign line because this is the function you're plugging into to get your signs, right? Wherever you got these numbers, that's what you're plugging into to get your signs, all right? If this is an F prime sign line, I'm plugging in I want the signs for F prime. F prime is negative means F is decreasing. F prime is positive means increasing. And there's my little arrows. Once you have your sign line, you are ready to write the answers. I had trouble today with that little extend page, so you have to see the graph in advance. That's okay. All right. So, Tyler, how are you? Good. Tell me, on what intervals is F increasing?
0. Oh, interval?
Yeah.
-1 to 2.
-1 to
0.
0,
And then 2 to infinity.
and then 2 to infinity. Good. How did you know that?
Because the sign is
Did you say the sign?
the sign.
Because
Because the sign. Because F is back or F prime is back.
there we go.
0 on.
Because F prime is positive on those intervals. You are never allowed to use the words the sign. Okay? You have to name by name what is positive. Okay. Yeah, Nitty.
So could you say those intervals instead of rewriting the
Yeah, you could say those intervals. That's okay. Yeah. Sometimes it's it's a potato. Sometimes it's faster to just say on those intervals, and sometimes it's faster to just rewrite the intervals. So, all right. Good. So, Nitty, since I got your attention, tell me the intervals where F is decreasing.
F of x is decreasing on negative infinity to -1.
Good.
And then the u
Uh-huh.
0 to 2
0 to 2.
because f prime of x is less than 0 on those intervals.
On those intervals. Good. When you have multiple intervals, you always separate them with a U. U means union, right? It's the union of those two sets. Another thing to know is that I will always write increasing and decreasing as open intervals. Your book, there might be a case occasionally, and I'm going to show you because we're going to have an example later on, where they might include an endpoint where the College Board doesn't care. Again, the College Board takes no stance on whether or not to include the endpoints, so they accept closed or open. There are times where if you write closed, you'll get it wrong, but you'll never get it wrong if you write open, so I always put open. Always open intervals, and then you'll always be right. So, always open intervals. All right, let's talk max and min. Let's see. Whoops. Hi, Tweakian. Hey, do we have a relative max anywhere? You can just tell me the x value. Oh, did you already find the y value? There you go. How did you get the y value? Where did you plug the 0 in? Are you sure? Into the original function. Whenever you need a y value, you plug into the original function. If we plug it into the derivative, what are we going to get every single time?
0.
0, because that's how you found the number in the first place, right? Okay, so the 0 is not a y value. 0 is a slope. We use our original function to get the y value, right? So Tweakian plugged in the 0 into the original function, and she's correct. It's fine. So relative max occurs at 0.05 y. Good. I am really lazy. I've never written out the word positive. I just put plus. Plus, 2, minus. On the AP exam, please don't put plus or minus. Put positive and negative. Okay, change from positive to negative at 0.5. All right. Here, Donna. How are you? Are you? Okay. All right. Do we have any relative mins? If you haven't found the y values, that's okay. You can just give me the x values. Where do we have a relative min?
Well, the relative min occurs at -1 and 5 and 2.
How do you know?
Because f of
Because F,
f of x changes from negative f prime of x.
there we go. Very good. At those points, yes. You know, I'm just going to write those points. At those points. Good job. All right. It's not because the function changes, it's because the derivative changes. So we need the y values. So at -1, I'm just going to quickly plug in, do a little mental math. We get 3 plus 4 is 7. Minus 12 is -5 plus 5 is 0, which is 0. Okay, so at -1 we're at 0. At 2, all right, this will be fun. 16 times 3 is 48. Minus 48 is 0, so you just get -32 plus 5, -27. 2, -27. The longest part of these problems is writing the answers, right? You can find a derivative in critical numbers and sign line in, a minute. It's the writing of the answers that takes a long time. Okay. Are there any questions on the process? No questions? Good. Then you're ready to try one with trig.
Ooh.
Okay. So I found out yesterday after school and again this morning that we are not all super confident in our trig. So we're going to just keep practicing, right? When we're not good at something, we don't avoid it. We jump on it. We tackle it and we repeat it and we do it again and again until we get good at it. So find the local max and min for g of x equals x plus 2 sine x on the interval from 0 to 2 pi. I didn't ask you the intervals of increasing and decreasing. I just asked you for the local max and min. So a little less writing of your answers, but apart from that, the procedure is exactly the same. So I want you in your groups, take a couple minutes, find the derivative, and then find the critical numbers. Be aware of the interval. You're only finding critical numbers between 0 and 2 pi, right? And then see what happens. Very pleased with how many groups figured out the correct critical number. So well done. So our first caution, what is the function called? G. So you had better be writing G's and G primes in all of your stuff, right? Okay. So, there we go. All right, so G prime equals 1 plus 2 cosine x. I'm going to set that equal to 0. I get cosine x equals -1/2. You have to know your trig. You have to know it. There's no way around it. There is no such thing as a trig cheat sheet or formula sheet or, no one's going to give you a unit circle on the AP exam. You just have to know it. It's got to be here. Everything's got to be in here. So you have to know what angle has cosine of -1/2. Now, personally, I know which angle has a cosine of 1/2. I know all my primary angles, and then I figure out all the rest by quadrants. So I know that cosine is 1/2 at pi thirds, right? Okay, and then I also know that cosine is negative in the second and third quadrants, right? So it's a pi third primary angle, but if I want the multiple in the second quadrant, I'd be at 2 pi thirds, and then in the third quadrant, I'd be at 4 pi thirds, because this would be, pi would be 3 pi thirds, right? So I get an x of 2 pi thirds and 4 pi thirds. And you need every single answer that's in the interval that you're given, right? So from 0 to 2 pi, there's going to be 2 answers for every trig equation except unless you're at an axis, right? So we make our sign line. Now, I was talking to one group about the sign line. When you are given a restricted interval, it's good to put those endpoints on your sign line. Because if you don't, you run the risk of accidentally saying, this is increasing from -infinity to 2 pi thirds instead of 0 to 2 pi thirds, right? So it's good if you put your endpoints, if you're given an interval, put those endpoints on your sign line so you don't accidentally go past them. All right. Pick an angle. So Emma, pick an angle between 0 and 2 pi thirds. Pi thirds. Okay. So if I plug pi thirds in, I get 1 plus 2 times the cosine of pi thirds, which I don't even need to know. I mean, it's a half, but let's pretend we didn't know it. All we need to know is that it's positive, right? Because you have positive plus positive, you are positive. Oh, I didn't label my sign. Okay. Positive. From there, my signs are going to alternate. If you're like at all worried, you can go ahead and find them. I would pick pi in here. What's the cosine of pi? -1. So you get 1 minus 2, which is negative, and then you're going to get another positive. So we are increasing, decreasing, increasing. All right, so let's write our answers. Hi, Alec.
Hi.
Do we have a local max anywhere?
Yeah, we do.
Where?
At 2 pi thirds.
Max occurs at 2 pi thirds, comma something. How did you know that?
Because you can see, like, when you draw the arrows, I use like your trick, and you can see that it's at the.
Okay, that's good. What would you write for the because statement?
You say because it changes from a plus to a negative.
Did you say it?
Or sorry, because f of x or g of x.
You're getting closer.
G prime f.
There we go! All right, because G prime changes, okay, dodged a bullet there, because G prime changes from positive to negative at that point. All right, so we need the y value. Where do I plug in to find the y value? Original function. So I plug 2 pi thirds into here. I get 2 pi thirds plus 2 times the sine of 2 pi thirds. Well, the sine of 2 pi thirds is positive root 3 over 2 times 2 is just root 3. So I get 2 pi thirds plus root 3. It is what it is, right? So all numbers are beautiful. 2 pi thirds plus root 3. Hi, Pranav. All right. Tell me where we have a local min. At 4 pi thirds, comma something. Why? Good. Okay, so I need to plug a 4 pi thirds into my original function to get the y value. I get 4 pi thirds plus 2 times the sine of 4 pi thirds. Sine is negative down here, right? Sine is your y. It's positive above, negative below. So sine of 4 pi thirds is negative root 3 over 2. Times 2 is negative root 3, so I get 4 pi thirds minus root 3. So 4 pi thirds minus root 3, which is a perfectly beautiful number. Right? Yes, Luke?
When you write g prime, do you have to write like the x?
No.
Is that right? Okay.
No. Just like you can write a function f or you can write f of x, it's the same thing. If the function's name is Fred, you can call it Fred, or you can call it Fred of x. It's just, the of x is just telling you what the input variable is. It's a courtesy, but the name of the function is still g. Yes?
Do we need to put the y value in one fraction?
No, I don't care about that. That's a very good question. No, the y value does not have to be simplified down to one fraction. Whew. Okay. All right. Any other questions before we move on? All right. Okay, we are on the next topic. I'm going to pause for 1 minute. We're going to do a little bit of Bad Joke Wednesday. All right. So, how do these graphs look similar? So, Tarun. tell me anything at all about these two graphs that is similar.
They start at A
And they,
and at B.
yes, they both start at A and end at B, right? Good. Is there anything else that is similar? Lucas, do you see anything? Oh, Casper had his hand up. Okay, Casper. Do you
I thought I saw something. You want to answer?
I was just gonna say they're both increasing.
They are both increasing. Yes. So you have two functions that are both increasing, but they don't look the same. Luke, what were you going to say?
It kind of looks like it's inverted.
Ooh, it's almost like one's kind of flipped over. Yeah, all right, what were you going to say?
I was going to say it's reflected over y equals x.
Okay, could be y equals x. Kind of looks like a y equals x reflection. Kind of look like inverse functions, right? Okay, so both of these functions are increasing. So that's the main commonality that we're going to focus on. But now we're going to think about how they're different. And this is harder. Oh, yeah, Brian.
Is f exponentially increasing and g is
Logarithmically increasing? Okay, so we don't know that for sure,
It looks like
but it looks like it, right? Okay, without knowing anything. Oh, yeah, Alec.
Are the derivatives like flipped?
Ooh, we are so diving deep into these. Good. I was for how they're different. Oh my goodness, Faith. Yes.
You know how like you use the tangent line to estimate values? The one for x would be underestimate, and one for g would be overestimate.
Oh my goodness, that is fantastic. That's like way beyond anything I was going for today, and that's 100% true. Well done. Yeah, Ishan, what's up? Oh my gosh, you guys are so smart. I mean, like, what am I even doing in here? Oh, that's awesome. Honestly, I was just going for one is shaped like this and one is shaped like that, right? Yeah, okay. So, all right.
There's a meme about the banana problem.
No, but I know the banana problem to which you are referring, and if you would like, sometime this year, we will do the banana problem. It's a famous problem from an actual AP exam maybe 2 years ago, so it's not that long ago. So, okay. All right. All right. No, you can talk about free response as much as you want. The College Board publishes the free response and all of the scoring guidelines for the free response and all of the discussions on the free response. Free response is yours to discuss as much as you want from 48 hours after you walk out of the test. For 48 hours, you're not allowed to talk about it. And then after 48 hours, you can talk about it forever. Multiple choice, you are never allowed to talk about ever until you die, right? And they will hunt you down and find you if they hear you talk about a multiple choice question. Because they like to repeat the multiple choice questions. But they'll never repeat a free response. So the problem with the free response, that 2-day thing, is because people take the AP exam all over the globe. And so you can't discuss it until like every single version of every single AP exam is closed and done, right? So they don't allow any discussion for 48 hours, and then after that, everybody can talk as much as they want. Anyway, all right, so this function is increasing, but here's what I'm going for mathematically. So if we look at the slopes start this, and then they're going like this. So what do you notice about the slopes on this graph? No, stop using the word exponent. We don't know it's an exponent. It could be parabola, right? They are getting bigger, right? So not only is the graph increasing, which means the slopes are positive, but the slopes are also increasing, right? So the slopes are positive and increasing. And your slopes are increasing. And the way that we write that is we say this graph is increasing at an increasing rate. Whoops, I just wrote rate. Okay. Increasing at an increasing rate. means the slopes are actually getting bigger. The slopes are increasing. Here, this graph is increasing, right? It's going up from left to right. But what's going on with the slopes? They're decreasing, right? So this graph is increasing at a decreasing rate. So it's increasing, but it's increasing slower, right? Think about which one would you like to have represent your salary over time, right? So pretending that there were arrows pointing on to infinity, right? Okay. Most people, it's actually this one, right? Especially teachers, but you want this one, right? Okay. So anyway, all right. Yeah, increasing. So slopes are positive and increasing. Slopes are positive but decreasing. So the way that we actually describe this is with a word called concavity. All right. When slopes are increasing, it means the function is concave up. When slopes are decreasing, it means the function is concave down. I personally like to say up like a cup, down like a frown. Some people like to say up like a smile, down like a frown. I like cup because it rhymes. Yes, Ishan?
Why is it like concave and convex?
Okay, so concave and convex, those are terms that apply to polygons. And there's really no convex here because there's no interior and exterior of the graph. There is only up and down. So instead of saying concave and convex, they say concave up and concave down. They're just talking about the concavity. While you are writing, I'm going to ask you a question. So you have to write and think at the same time. On this graph, let's make sure I can do it. Yep. On this graph, I'm saying this is concave up. I'm saying the slopes are increasing. Yet on the left-hand side, the slopes are getting shallower. How can they be increasing if they're getting shallower? Because they're negative. So this could be negative 100. This could be negative a half. Numerically, they are increasing. Does that make sense? So we don't care, like increasing doesn't mean steeper necessarily. If the slopes are negative, it actually means shallower. We're just talking numerically increasing. So just know, no matter what, if the graph is shaped up like a cup, like if this was a bowl, it would hold stuff, right? That means that your slopes are increasing from left to right. If the graph is concave down, that means it's like a bowl turned upside down. If you poured cereal in, it just bounced all over the place, right? That means it's concave down, which means your slopes are decreasing. All right. The spot where the concavity changes is called a point of inflection, or an inflection point. So we say inflection. Point of inflection. Okay. So, point of inflection is where the graph changes concavity. For example, if this went concave down to concave up, that would be a point of inflection. All right, does every change in concavity result in a point of inflection? Not necessarily. Just like every change in the derivative from positive to negative doesn't result necessarily in a relative max that you could write as an ordered pair. Yeah. So yeah, exactly. You could have a hole there. So for this, if we have a graph that is discontinuous, same thing with maxes and mins. I almost second guessed myself, but I was right. If we have a graph that's discontinuous, like say for example 1 over x, you're concave down, you're concave up, you've changed concavity, but there is no point of inflection because there is no point there, right? It doesn't even exist at 0. So you can change concavity without a point of inflection if the graph is discontinuous there. You have to check. But the good news for you guys is since I make you write those big long because statements for every single answer, as soon as you plug the x value into the original function to get the y value for the point of inflection, you'll get a nothing, and then you'll know there's no point of inflection, so you'll be fine. So anyway, yeah, every change in concavity is not necessarily a point of inflection if there's discontinuity. All right, does everyone have, what I'm really looking for is like those three things, right? And do you know understand the shape? The first problem we're going to do, we're not going to do any of the math. We're just going to kind of look at it and talk about it. Oh, wait, I lied. Okay, we're going to do this. Then we're going to go back and do the concavity test. Okay, so the graph below is a population graph for Cyprian honeybees raised in an apiary. Okay, you don't have to write this down. How does the rate of population increase over time? When is this rate the highest? On what intervals is P concave up, and on what intervals is P concave down? So in your groups, take 5 seconds and just see if you can figure out roughly at what time do we have a point of inflection. At what time does the point of inflection occur?
12 weeks.
Who wrote there?
All right, good. Hey, Shirley. Hi. Okay, what time did your group say the point of inflection occurred? Around 12. Okay, and that's fine. Like anywhere, like I took like 10-ish, 11-ish, 12-ish. Anywhere around there is totally understandable, right? It doesn't. We don't know for sure. It's somewhere around there. So let's just say it occurs at 12, right? So if roughly at 12 weeks we have our point of inflection, from 0 to 12, this graph is what? Concave up. From 12 to 18, this graph is
Concave
down. What that means is the population growth rate, the rate of change of the population is increasing and then decreasing. So rate is increasing, rate is decreasing. Now the population's increasing the whole time, right? But it's increasing faster, 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 and then all of a sudden it starts slowing down. It's still increasing, but it's increasing slower. So, let's see. When is this rate the highest? The rate is the highest right there at the point of inflection. Because the rate was increasing, and then the rate was decreasing. Okay? The population's increasing the whole time. It's not saying where is the population the highest. It's saying where is the rate of change the highest. Yes, Misha?
So is the rate always going to be the highest at that point?
If you are doing a concave up to a concave down, and there's nothing else going on, yes. So this is actually, there's a specific type of name for this kind of a curve. It's called a logistic growth curve. We will get into this later on. But they always end up doing this concave up to concave down, highest rate of point. Yeah.
So if it goes from a concave down to an up, would it be the lowest rate?
Very good. Very astute. All right. It's time to learn our second test of the day, which is the concavity test. So now we're talking about finding where the rate is increasing and where the rate is decreasing, which means we need to figure out the slope of the derivative. So if we have to find the slope of f prime, we're using f double prime. So concavity is all determined by the sign of f double prime, because it's whether the rate is increasing or decreasing. So when you are finding concavity, you find your second derivative. So you're going to have to find the first derivative, and then the second derivative. So find the second derivative, you make a second derivative sign line, and then you write your answers with because statements. There are only 3 for concavity. By the time tomorrow is over, you will have learned and memorized 9 because statements.
Just two more.
Just two more. There are some abbreviations that I didn't put in these statements that I will show you when we do the next problem. So you can see how you can abbreviate. Yes, Jennifer. So the third statement, a point of inflection occurs because F double prime changes sign. Yeah, don't say positive to negative or negative to positive. Just say changes sign. Yeah, points of inflection, a relative max, you have to change from positive to negative. There's no way around it, right? But a point of inflection, it doesn't matter which way you change as long as you change. So the College Board has told us in these lovely annual workshops, they have mentioned, by the way, please tell your students to stop writing positive to negative and negative to positive for their points of inflection because they always mix them up and get them wrong. And if they just said changes sign, they'd get them right. So just write changes sign, and then you'll be fine. Those are the kind of things we learn at these workshops. That's one of the main reason I like going is because I learn these little, like, make sure your students do this and make sure they don't do that. Your hand is tired? Too much writing? All right, we have one more problem. We're going to walk through this together because I want to make sure we get through it before the bell rings, okay? Does everyone have these three things, everything written down?
Yes.
Okay. All right, last problem of the day. We're going to do the works. We're going to answer every single thing we've learned today in this one problem. The function is x to the fourth minus 4x cubed. We're going to do increasing, decreasing, max, min, concave up, concave down, points of inflection, and if there's 30 seconds left, we're going to sketch that curve. Boom. All right? Heck yeah, we are. You can do this, Anthony. Yes. All right. We're going to start by finding y prime. All right, everyone together, yell out y prime.
4x cubed minus 12x squared.
Good. That was so enthusiastic. All right. So we've got that. I'm going to pull out a 4x squared. So I end up with x minus 3. Critical numbers at 0 and 3. Did everyone get that? Make sure you check my math because I don't know the answer to this, and so I might mess up. Plus or minus 0. All right. So actually, as Ryan just pointed out, 0 has an even multiplicity, right? Which means our sign is not going to change around the 0, but it will change around the 3. So what ends up happening is if I plug in a 10, I get positive, positive. So I'm going to go positive, negative, negative. Oh, and I'm going to label my sign line. I'm going to put my little arrows in. I am decreasing, decreasing, increasing. All right, I'm going to go ahead and start writing my answers for the first half of this problem. So I'm going to say y is decreasing on. This is where I might be different from WebAssign. So I just warn you now, I like to separate my intervals. So I personally would say negative infinity to 0, union 0 to 3. College Board loves that answer. They totally accept it. It's fine. A lot of resources want to include the 0 in the interval. And there are reasons for it, right? Because there's two different definitions for decreasing. So some people say you are decreasing when the first derivative is negative, and some people say you are decreasing when the point to your right is higher and the point to your left is lower, right? So because there's two different definitions, there's two different ways to write the answers. College Board has said we aren't going to take a stand, so they accept either way. All right, so anyway, y is decreasing on those intervals because y prime is negative on those intervals. All right, y is increasing on 3 to infinity because y prime is greater than 0 on 3 to infinity. All right, Gavin, do we have a relative max? Why not? Okay, because the derivative never changes from positive to negative, right? So, do we have a relative min? Where's the relative min at? What x value?
3.
At 3. So, a rel min occurs at 3 comma something because y prime changes from negative to positive at 3 comma something. All right, plugging the 3 in, just so you know, life is always easier when you factor. So if I rewrite my original function as x cubed times x minus 4, now I can plug in my 3 and I get 27 times negative 1, so negative 27. All right, we're done with the first derivative. Let's move on to concavity. All right, yell it out. What's y double prime?
12x squared
Minus 24x. All right, you're doing the exact same thing with y double prime that you just did with y prime. So I get 0 and 2 for my critical numbers for y double prime. All right, make a lovely y double prime sign line. I'm labeling my sign line so I don't get it confused with my y prime sign line. All odd multiplicity. It's a parabola opening up. It's going to go plus minus plus. So, up. Oh, whoops! Sorry. Don't write that. I forgot we're doing concavity. When we're doing concavity, when your second derivative is positive, I put little like concave up symbols. And when your second derivative is negative, I put little concave down symbols. Yeah, sorry, I didn't need to write this. I got ahead of myself or behind myself. All right, let's do concave up. Y is, I abbreviate concave up by drawing a little concave up symbol. Y is concave up, don't do that on the AP exam. Y is concave up on negative infinity to 0, union 2 to infinity, because y double prime is positive on those intervals. Y is concave down on 0 to 2, because y double prime is negative on 0 to 2. Do we have any points of inflection?
Yes.
Yes. Brian, what are the two x values for our points of inflection?
0 and 2.
POIs, it should really be P's OI, points of inflection, not point of inflections. But POIs occur at 0, comma something, and 2, comma something, because y double prime changes sign at those points. Where do I find the y values?
Original equation.
Original function. I plug in a 0, I get 0. I plug in a 2, it's a good thing I factored it, I get 8 times negative 2, I get negative 16. We did a lot of writing. We have time to sketch the curve.
Yeah.
Okay. Now, there is a specific method that I want you guys to use for sketching a curve, which I'm not going to teach you right now because there's 2 minutes of class left. But just see if you can kind of follow my reasoning. From negative infinity to 0, we are decreasing and concave up. And 0, we're at 0. We're at point 0, 0. So decreasing, concave up. Then from 0 to 2, we're decreasing concave down. So I'm going to go whoop. Pretend that looks better. Okay, from 2 to 3, we are still decreasing, but we're concave up. Whoop. And then from 3 to infinity, we are increasing concave up. Whoop. And there's our beautiful graph. Gorgeous. You did it. Biggest lesson of the unit. So well done, guys. Video is over an hour long.